and matrix. Scroll to the right to edit. And we are going to edit a matrix that is so-called 3 by 4. 3 rows, 4 columns. So 3, enter, 4, enter. And now we enter by rows. 600, enter, 63, 112, 144, 720, 142, 355, 459, 93, 51, 119, 127. Let me know when we have this. Is anyone working with me on this?
I missed how to set it up on the calculator.
So second matrix. Enter a 3 by 4. And enter the information by rows. Do we have it? Yes?
You said second matrix, and then I see names, math, and edit.
You have to edit. We're editing a matrix. Okay, ready?
Yes.
Okay, so then go to stat and go to tests and look for the chi-squared, not the chi-squared goodness of fit, just the chi-squared test, and press enter. And if you have the observed matrix in A, like I do, just move on, scroll down. The expected will be automatically saved in matrix B. And then I want to draw. And now we're going to also see, unless I have something else in there, which I probably do. And I do have, so hold on just 1 second. I forgot to check. I have, okay. I had used the calculator with some, with my calculus class, and I had 2 functions in there, and I forgot to delete them. Okay, here it is. So here's the chi-squared for 6 degrees of freedom. And I get, anyone can confirm, I got the chi-squared equals 224.1156 unless I enter something and p-value 0. So I'm going to check now. Make sure my matrix is correct. 663, 112, 144, 720, 142, 355, 459, 9351. Yep, it appears that is okay. I'm going to check now the expected and copy it. So this is the matrix of the observed values, AO if you want. And this is matrix B for the expected values. So 435.02, 78.8, scroll to the right, 180.41, 224.75. Can anyone confirm? Did you get anything, any near what I'm getting? Can anyone confirm? Anyone? 793.36, 143.74, 329.02, 409.88, 95.38, 76.56, 33.44, and 184.61. Can anyone confirm? Anyone? Is anyone working with me on this? Did we get the same chi-squared? Of course, this is a chi-square statistic. Anyone?
Is the attachment posted in modules? Because I haven't finished my data table.
Yes, the handout is always posted in the video lectures and lecture notes for the entire semester. It's the updated one from last time. Did you find it? Okay, since the p-value is 0, no matter what level of significance, we reject the null hypothesis, and we conclude that there is sufficient evidence. There is sufficient evidence to conclude that they are not independent. The variables are not independent. What variables? Marital status and happiness. That marital status and happiness level are dependent, are not independent, based on this sample. Okay, so that was an example of the test, the chi-square test for independence. Now let's look at the chi-square test for homogeneity. And by the way, now we are ready to make sure that the conditions are fulfilled. And as you see, not only that they are greater than 1, they're far more greater than 5. Okay, so the conditions are fulfilled, so the test is acceptable for this condition. Okay, so let's take a look at the test of homogeneity. Okay, so let's read the problem. Zocor is a drug that is meant to reduce the level of LDL, the bad cholesterol, and increase the level of good cholesterol. In clinical trials of the drug, patients were randomly divided into 3 groups. Okay, so I'm going to copy the table or directly the matrix of the observed. So it's a 2 by 3, 2 rows, 3 columns. So 51, 1532, 5, 152, 16, 163. So these are the 3 groups in question. The first group got Zocor. The second group did not get anything. They got placebo. And in group 3, they received a different competing drug. Data from below presents the number of patients in each group who did and did not experience abdominal pain as a side effect. So this one, they experienced pain. This row, they did not experience pain. Is there evidence to indicate that the proportion of subjects in each group who experienced abdominal pain is different at alpha 0.01? So they know, and the alternative for homogeneity of proportions are these. So the null hypothesis, P1 equals P2 equals P3. The alternative hypothesis, at least one of them does not equal the other two. At least one is different. Okay? We enter the data. Go back to second and matrix. We're going to edit now a 2 by 3. And that will be 51 and 5 and 16, 1,532, 152, and so it's a 2 by 3. Okay, we didn't take it for some reason. So 51, 5, and 16 is okay. 1532 is okay. 152 is okay, and 163. I will conduct a test. It's a chi-square test, A and B. I'm going to draw and see what happens. So I have that the chi-squared statistic is, for some reason, it did not, it still gives me the values from before. Be careful if that happens. Maybe I have to it automatically, careful, because the calculator may jump to a different matrix. Be very careful with that. This is not the first time this happens to me. I don't know why it does that. So careful. Maybe just my calculator does that. Maybe the older ones do not do that. Okay, so I conduct a test. And now it's in A, and it's okay. So the chi-squared statistic, okay, I see it. It's 14.7065, and the p-value 6 times 10 to negative 4. Almost 0. The p-value is less than alpha. I need to see the matrix of expected to make sure that the conditions are fulfilled. So let's go to a second and matrix and go to matrix B. Let's take a look. 59.39, 1523.61, 5.89, 151.11, and the last column, 6.72, 172.28. They're all greater than 5, so the test is okay. And our conclusion would be that we reject the null hypothesis, meaning at least one proportion is not equal to the other two. The other two. So the way we present this, we'll say there is sufficient evidence coming from the sample to conclude the above. And that's it. That's the end of the course. So what I would like to do